Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 4 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 1390, 4 divisors. So in this problem you are given an integer array nums. We have to return the sum of divisors of the integers in that array that have exactly 4 divisors, right? If there is no such integer in the array, return 0, right? So see this example number 1, right? So let's pick first 21. So 21 has 4 divisors, right? 1, 3, 7 and 21, right? Because 21 is completely divisible by 1, right? We are going to get remainder 0. 21 is completely divisible by 3, we are going to get remainder 0. 21 is completely divisible by 7, we are going to get remainder 0. 21 is completely divisible by 21, so we are going to get 0, right? Okay, so 21 has 4 divisors, that is 1, 3, 7 and 21. Same way 4, so 4 has 3 divisors, right? So 1, 2 and 4. Same way 7 has 2 divisors, right? But we only need to know these 4, right? Because it is saying that return the sum of divisors of the integers in that array that have exactly 4 divisors. So this has 4 divisors, right? So what is the sum of all these? 21 plus 7 is 28, 29, 30, 31, 32. 32 is the output. That's it, right? Same way here, this 21 has 4 divisors, that is 1, 3, 7 and 21. And this 21 also has 4 divisors, 1, 3, 7 and 21. Here we are going to get sum as 32. Here also I am going to get sum as 32. So total sum is nothing but 64. 64 is the output. That's it. Here none of them has 4 divisors, right? So 5 divisors is nothing but 1 and 5 only. 4 is nothing but 1, 2 and 4. 3 is nothing but 1 and 3. 2 is nothing but 1 and 2 only. 4, 1, just 1. So none of them has 4, exactly 4 divisors, right? So output is 0, right? That's it. And these are the constants. Nums dot length is from 1 to 10 to the power 4. And nums of I values from 1 to 10 to the power 5, right? So here, see one thing. 36. Let's see this number 36. So I can say 1 into 36 is equal to 36, right? So 1 is one divisor and 36 also one divisor, right? From here this is clear, right? 1 and 36 both are, right? Same way 2 into 18, so that's equals 2 and 18, right? Okay, 2 into 18 is also 36. Okay. 3 into 12 I can write. So 3 is also divisor of 36 completely providing it, right? And 12 is also 1, right? Okay. Then 4 into 9. Good. So 4 also add it here. 9 also you can add it here, right? There are so many, right? For 36. Okay. After that 5, I don't think so. 6. Yeah, 6 into 6 is there. So all these are equal to 36, right? All are equal to 36. So here you add. Now here one thing. This and this both are same, so you have to just add 1 only here. You don't need to add 2 6s, right? Okay, clear this thing, right? Right. Now after that, can I proceed further? 7, no. 8, I don't think so. 9 will get 9 into 4. 9 into 4 is good 36. Okay. After 10, 11, 12, you will get 12 into 3, right? Then 13, 14, 15, 16, 17, 18 you will get 18 into 2. Then 19, 20, then directly I think 36 you will get, right? Now see here the important thing. I have already added 9 and 4, right? 12 and 3 is already there. 18 and 2 is already there. 36 into 1 is already there. 36 1, right? So these things are repetitive ones, right? Just the opposite of these, right? 36 to 1, 1 into 36, 2 into 18, 8 into 2, right? 3 into 12, 12 into 3, 9 into 4 or 4 into 9, right? So these things are repetitive ones. Why I need to check? No need to check these, right? Because here I have to do one thing. I have to run my I loop from 1 to 1 2, when my I into I, it should be less than equal to this particular number 36, right? Until here only I need to run, right? And here I plus plus. So from here, see, this is nothing but I can say I am running my I loop from I is equal to 1 to I square less than equal to 36, or I can say I is less than equal to square root of 36, which is nothing but it's 6 only. So see here, I plus plus. So now I am just running my loop until math dot square root of num, and I will find out all the divisors, right? I will find out all the divisors, right? Very easy. I don't need to check until 1 to 36, right? Now my loop is running for very less time, just for square root time. So I can write like this: I is less than equal to math dot square root of num, or I can write it like this, same thing, right? Okay, so this thing is clear, and we are going to add this and this to the divisors list. Okay, to the divisors that I have, but I also need to make sure that both are not same, right? Here both are same, right? So I have to add it like this. And once everything is done, right? Once everything is done, right? Side by side I can do one thing, na? Side by side also I can do the calculation plus of all this, right? Plus of all this, right? And little bit more optimize, I can optimize my code little bit more. If I just count the number of factors, 1 2 3 4 5, no, I need exactly 4. So as soon as I cross 4, just break it. That simply means 36 has not exactly 4, right? 4 divisors. Move to the next number. So now it is very easy, right? Only these few things I need to take care, right? So let's write the code, nothing complex, right? So here int sum is equal to 0, and then you have to use enhanced for loop, int num in your nums, right? And here inside this, int divisor count, right? How many divisors are there? So as of now 0, right? And let's say divisor sum, so this is also 0 as of now, right? And after that, I told you that inside this you have to just run one loop, right? Int I is equal to 1, I is I into I, you can write, okay, it should be less than equal to the num, right? And here I plus plus, and here just check if num is completely divisible by this I, right? So if the remainder turns out to be 0, then only we need to consider the factors. So let's say d1 is equal to I, and d2 is going to be nothing but num divided by I, right? Why I'm saying that? Okay, see here. So 36 is completely divisible by 1, right? So one factor is 1 and other is 36 divided by 1, that is right. 36 is completely divisible by 2, right? So one is 2 and other is 36 divided by 2, that is correct, right? Because overall if I just multiply, I will get always 36 now, right? I will always get 36, right? If 3 is completely divisible by 36, right? 36 completely divisible by 3, right? So 3 and other is 36 divided by 3, so that is nothing but 12, right? So if I do multiply it now, you will get 36 only, right? So this is what I'm doing here, right? Clear this part, right? Now here divisor count, increment it, right? Divisor count, increment the divisor count, right? Divisor count plus plus. Also here, now divisor sum, in divisor sum you have to add what? I'm incrementing just 1, I'm not incrementing 2 as of now, just 1, okay? And here I will just add d1, just d1, I'm not adding d2 right now. I will add d2, but first I have to make sure that my d1 is not equal to d2, right? So if this is the case, right, then in that case only I will increment the divisor count, and this time I will add d2, right? Very basic thing, right? Clear this thing. And here early exit I will do, right? So if my divisor count, right, if divisor count, if it becomes greater than 4, break it. I don't need to check further, right? That's it. That's it. Okay, now this is done, right? Now here once this is done, right, once this is done, right, so I am only breaking when my divisor count is becoming greater than 4, but I'm not breaking when it is just 1, 2 or 3, or it is exactly 4. So I need to check, right? Maybe only two factors are there, maybe only two divisors are there, not exactly 4. So now I need to check here if divisor count, if it is exactly 4, right, in that case the sum value is going to be sum plus the divisor sum, right? So here you can add this divisor sum, right? Okay, so now see here, here your complete loop ends, right? This complete, after iterating over all the nums, then only you have to return the sum. That's it. Okay, this is your code. Let's run it. So see, all the test cases has been accepted. Now let's submit it. So see, our solution is accepted, right? Okay, and here if you see the time complexity, it is nothing but n into square root of m, right? That's it. So n numbers we are checking, right? So of n here, and there is one nested loop, right? So for all these numbers we are checking the factors, the for one particular number, right? For that particular number we are checking the divisors, right? So here, and it is running for square root of m, let's say, right? So square root of m. So overall n into square root of m is going to be the time complexity, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.